Good morning, children. I hope you are revising your lesson. The other day, I taught you the characteristic properties of gases, and I had uploaded a video also. And I'm sure you studied in classes 7 and 8 as well. Today, we're going to start with what is absolute zero? How do I define absolute zero? Absolute zero is the lowest possible temperature that is theoretically possible at which the molecular motion completely ceases. It corresponds to minus 273.15 degree Celsius on the Celsius temperature scale. At absolute zero, molecules have minimal kinetic energy or it's equal to zero. Now, what do we understand by it? In simple English, it means at absolute zero, the molecular motion ceases. The kinetic energy is zero. It is a theoretical concept, but in laboratory it is not possible, because if you're going to a temperature say around minus 273.15 degrees Celsius, there may be a change in their state. So once more, absolute zero is the lowest possible temperature that is theoretically possible at which the molecular motion completely ceases. It comes to a halt. It corresponds to minus 273.15. You can also mention minus 273 degrees Celsius. That is good enough. On the Celsius temperature scale, at absolute zero, molecules have minimal kinetic energy or it is equal to zero. Now, how do the gases behave? Okay, and what are the three variables that we are going to study with respect to gases behavior? So the three variables that you're going to study is number one, volume, number two, pressure, and number three, temperature. Volumes is denoted by letter V, pressure by letter P, temperature by letter T. Now, how do we measure it? What is the SI unit and the other units in which you measure these variables? Very important, especially while calculating the numericals based on it. The SI unit of volume of a gas is meter cube. But it is seen in the numericals, it may not be given in meter cube. They might mention centimeter cube, milliliter, decimeter, and liter. You have to be acquainted with these units as well. Keep in mind, 1 decimeter cube equals to 1 liter. Is that clear? 1 decimeter cube equals to 1 liter. Now the next is SI unit of pressure. SI unit of pressure is Pascal. Okay, and in short form you write PA. Okay, other units are atmosphere, which is in short you write ATM. It is also measured in centimeter of mercury, millimeter of mercury. Now what is the conversion? 1 atmospheric pressure is equal to 76 centimeter of mercury, which is also equal to 766 millimeter of mercury, which is also equal to 760 torr. Once more, 1 atmosphere equals to 76 centimeter of mercury, which is also equal to 760 millimeter of mercury, which is equal to 760 torr. Generally, we don't use this unit torr. However, you should be knowing it. Now let us move on to SI unit of temperature is Kelvin, and it is written denoted by letter K. Now other temperature is degree Celsius. I am sure you are acquainted with degree Celsius. Now how do I convert Celsius into Kelvin? So Kelvin equals to Celsius plus 273. Suppose you are given to convert 100 Celsius into Kelvin. What do I do? 100 Celsius plus 273 gives you 373 Kelvin. Are you with me? Now let us move on to pressure and volume relationship in gases. Very important. Now we are coming to the core of the chapter. Number one, when the temperature of a fixed mass of a gas is kept constant. So what is kept constant? The temperature is kept constant and the pressure is increased. The volume correspondingly decreases. Very obvious. So when you apply pressure on a fixed volume of a gas, okay, what happens? When you increase the pressure, the volume correspondingly decreases. That means the volume of the gas will decrease. Number two, when the temperature of a fixed mass of a gas is kept constant and the pressure is decreased. So what are you going to do? You're going to decrease the pressure. Then what happens? The volume correspondingly decreases. So the second point is when the temperature of a fixed mass of a gas is kept constant and the pressure is decreased, the volume correspondingly increases. Now let us begin with Boyle's Law. Very important. And you are going to study what is Boyle's Law, the mathematical expression, how you derive the law, the Boyle's Law equation, and then graphical representation, and of course numericals based on Boyle's Law equation. Very important. Now what did Robert Boyle state? Volume of a given mass of a dry gas is inversely proportional to its pressure at constant temperature. So Boyle's law states that volume of a given mass of a dry gas is inversely proportional to its pressure at constant temperature. V stands for volume. So volume is inversely proportional to pressure when you keep the temperature constant. This was the findings of Robert Boyle, and the law was named after him, Boyle's Law. Now you can also state it differently. Boyle's law may also be defined as the product of the volume and pressure of a given mass of a dry gas at a constant temperature is always a constant. That means the product of pressure and volume is always equal to K, a constant. So you can define volume is inversely proportional to the pressure when the temperature is kept constant, or product of pressure and volume is equal to a constant when the temperature is kept constant. Are you with me? Now let us begin with mathematical expression of Boyle's law. How do I begin with it? Let a particular mass of gas, any gas, occupy volume V1. V1 means initial volume. When its pressure is P1 means initial pressure. Then, according to Boyle's law, V1 varies inversely as P1, 1 by P1, or V1 equals to K upon P1. Now, P1, V1, the product of initial pressure and initial volume is equal to K or constant. Now let us take it this way. If V2 is the volume occupied when the pressure is P2, the final pressure is what? P2. At the same temperature, that means the temperature is kept constant, then V2 varies inversely as pressure P2, or V2 equals to K divided by P2. Now from this expression I can write P1 V1 equals to P2 V2, which is equal to K, a constant. Now, what is Boyle's law equation? Boyle's law equation is P1 V1 equals to P2 V2. You are going to solve the numericals based on this law, Boyle's law equation. What is it? P1 V1 equals to P2 V2, meaning the product of the initial pressure and initial volume is always equal to product of the final pressure and final volume. Is that clear? Now let us go through the graphical verification of Boyle's law. The first one, volume is inversely proportional to its pressure, is always a straight line graph passing through the origin. So look at the volume axis and the pressure 1 by P. What kind of graph do you obtain? You obtain a straight line graph when you plot it passing through the origin. Is that clear? Now the second one is volume versus pressure, right? So this axis, okay, is the volume axis. This axis, okay, the horizontal axis is the pressure axis. What kind of graph do you obtain? A hyperbolic curve. So remember, when you are plotting a graph, volume versus pressure, then you get a hyperbolic curve. Is that clear? Now let us take a look at the last graph, the vertical axis, which is y-axis, and the horizontal axis is the x-axis. Okay, now look at this graph. The product of pressure and volume you're plotting, and the x-axis, look here, is the pressure axis. When you plot the graph, you see that a straight line is obtained which runs parallel to the pressure axis. So these three graphs are verification of Boyle's law. The first one is volume is inversely proportional to its pressure. You get a straight line graph passing through the origin. Now, when you take volume versus pressure, then you get a hyperbolic curve. When you plot the graph, for instance, product of pressure volume by pressure, then you always get a straight line graph which runs parallel to the pressure axis. Please revise the chapter thoroughly so far whatever we have completed, or else I'm telling you, when we start with the numericals, things will appear to be very blurred. Okay, so do revise whatever is being taught to you and update yourself. Thank you.